All right, let me go and pull up chat on Twitch. Okay, good. And let's see what happens on it. Let's see. Okay, good. Chat room's open. Welcome, everyone. I need to stop the sound from coming in to my ear. Hold on a second. All right. Yeah, I can hear myself in my ear.
Oh, that's really annoying.
Yeah, that's got to stop. All right, for those of you who are watching, this is Eric Gross, and we are going to be building a MERN application in public, but I can now hear myself in my ear, and that is driving me up a wall. So give me just a moment. All right, can you hear me?
Yes, sir.
Yeah, it's still doing it.
Did you do anything different today from did you mess with any of the settings from last Wednesday?
Give me that again.
Did you change any of the settings from Wednesday to today?
Nope, I figured it out. The Twitch stream itself was playing on about a 3-second delay. Okay, good. Oh, excellent. All right, so we're going to get to work here. Again, let me kind of explain what we're doing. We're doing a several-part stream here where we're just trying to show what it's like to actually make, a relatively standard full-stack, web application. But we're doing so not in a tutorial format, but in how it would really go down with all the kinks there are. Right? We know where we're going in general, and we know we can solve anything that comes up along the way, but real world software development is not like what you see in a tutorial, and we just kind of wanted to demonstrate that. So what we have kind of mocked up here is that we have this little 3-man team, a development team. I'm the tech lead, and I've got 2 developers working with me, Carolina and Brandon, and we're just going through building an actual full stack web application. In our first session, we went through a bunch of design phase where we kind of just put together, what's the situation, what's the problem that we have, and we kind of wrote that up here. Where we have design notes. We have a typical modern retailer, and they have internal customer service reps. And these customer service reps take inbound calls and they place orders for customers. And they've been doing everything manually for the most part, or with Excel spreadsheets, which is a not uncommon situation. And they need an application that'll help them do their work and eliminate a lot of inefficiency and save time and be worth the cost it takes to actually build an application. So quick review of where we're at, and then we'll jump into some development. We documented the existing manual process, which we're going to come back to at various points simply because it gives us some insight into the sequence of actions that'll have to happen and the type of functionality we're going to have to implement for our actual computer program. But I'm not going to review all those in detail. But our proposed solution is we're going to build an application that's centered around the customer service rep. It's their portals, their workspace throughout any given day. It gives them access to information about customers. Also, they can create new customers as needed. It lets them see order history and the status of any particular order. It lets them look into a big database of product. They can't add product or delete product, but they can certainly assign products to an order, and they can review the products that are there. And we further went on and we got a little more technical and started designing for this computer program, what are the objects or entities that we might need to provide functionality around. It came up with 4 particular entities: customer, order, product, and address. And if you're curious as to why an address is not part of a customer, review that first session we did. We had a whole discussion around it, and it's pretty valuable information in terms of software design. after we had, gotten to the point we understood the 4 entities, we started looking at their actual properties, like what are the things we care about on each of these. And we have all the different properties here for a customer, for an address, for an order, and for a product. And then we started listing out, well, what are the actual functionality? What's the functionality we need to put into this thing? Well, we talked about the create, read, update, delete acronym, CRUD. And for 3 of these entities, we're going to have full create, read, update, delete capability. When it comes to products, in general, we're only going to read product information. We are going to update it only specifically that a product includes how much of it we have on hand, includes a quantity and inventory. That we're going to allow the customer service reps to change, but they can't change anything else about a product. And we have a few design notes, some stuff around how we search for customers, and we already handled this one, the place of freeform info on customers. We already got that, which is great. We then went on and started to design the application a little bit in terms of a front end and a back end. And right towards the end of the session, we got to the point where, as the lead engineer, I had started creating the actual default application that's going to be on the server. It's our API. It's an application that will take HTTP requests surrounding CRUD operations for all 4 of these entities, and it'll actually implement the logic. It'll interact with the database, do any operations it needs to there, and it'll send a response back to whoever sent in the request. Tonight, what we're going to do is flesh that out a bit more, and then we're also going to start work, if we have time on it, on building that front-end application, a nice graphic user interface, a GUI, that the customer service reps will use to actually, have a place to do this work. And it is that application that lives in a user's browser that will send these HTTP requests into the API. So there's 2 projects we're actually building. So in terms of time, we'll probably spend about 2 hours tonight. And I think, honestly, we'll probably just end up building out the basics of this back-end application, and get both Brandon and Carolina set up where they also have the exact same code on their machines and can start to build out some of the functionality. So we're primarily going to concentrate on the back-end application for today. So that's where we are, right? And now that I want to just make sure that our program is up and running where we thought it was, and orient ourselves to what we're doing, okay? One thing I want to make sure that I pay attention to is whether or not the chat is actually working, because last session, there was a setting that was wrong with my Twitch account and people couldn't chat. And that was very frustrating, and I felt pretty bad for people because we had some people watching. So if you are watching right now, I see that we have 4 viewers. If you can throw something in the chat room right now, that'd be great. If it's not working, I would super appreciate it if you go out on Twitter, and send me a DM. I am Eric David Gross, ERIK, Eric David Gross on Twitter. And if it's not working, I want to know about it, because I haven't seen any chats come through. And we'll see what we can do to actually change the settings on that. Okay, so you guys ready to start looking at this application and building out a few things?
Yes, ready.
Okay, good. So
I asked a friend to send a message. He's watching, so we should have something coming through.
Good, excellent. Let's watch that. I would like to get that straightened out so we can not have to worry about it. Chat settings. Show moderation actions, appearance, first time chat highlight. Followers only chat. The 0 minute wait. Straightened out so we can not have to worry about it. Yeah, I have it set to followers can chat if they have.
Okay, yeah, okay.
Oh, off. Remove followers only. They don't have to be a follower.
Yeah, okay.
Okay, good. I changed that. Hey, Keluko.
That's me.
All right. It worked. That's fine.
Okay, cool. Yeah, but you do have to follow, which I don't like that, I think. Okay.
Yeah,
okay,
so
cool.
I took that off. You don't have to follow. Anybody can. Awesome. Technology's fun. Okay, good. So I'll watch that chat. Okay, so let's get this application up and running again. And just to refresh all of us here, because I've got to get back into the context of where we are. We have a Node application. So it's written in JavaScript and it's meant to run on a server. And we added into our default Node application a library called Express, which is a web framework. It handles a lot of the nitty gritty of receiving HTTP requests and composing HTTP responses that can be sent back. What we've done so far is just simply configure our application in this package.json folder to make it so that when our computer program starts up, that the place it looks for the first code to start executing is in a file called server.js. And in that server.js file, we've done only a couple of simple things. We bring in some libraries that we're going to need for the code in this file. The most important one is this Express library. And then on line 5, this is the first line of code that really actually does something of significance. It spins up a running web application using that library called Express. So from that point down, we now have an actual live computer program running in memory that we can start to configure the way we want to. The first thing we do is we configure a route handler for it. And what this says is, if we have an incoming HTTP request, and that HTTP request is of an HTTP verb type get, and there's several HTTP verbs, that's something you should look up if you don't know much about it. If we get a get request, then we're going to compose a response formatted as JSON, and the content of the response that gets sent back to whoever the requester is this key value pair. The key is message and the value is you made it. Let me change that to the root of the app. So let's run this thing. If we go down to the bottom here, we run npm start. What it'll do is it'll go to the config.json, and you'll see I need to go to server.js, and it'll go to server.js and start executing code. So it goes to server.js, and you can see this message in the console log of servers running on port 8080. That tells us that our application is listening. That's the second thing, the third thing we did of any importance in this server.js file. We are listening on port 8080 on the local web server. Our machine has a web server on it like any modern PC. So now that we know it's listening, let's test again what happens if we actually send any kind of a request to that port. Do you guys know that when you go in here and you type in some kind of a URL and hit enter, that the type of HTTP request that's sent is a get verb? That's what browsers send. Did you guys know that?
No.
Yeah, just by default, from this line right here, if you were to type like google.com, not goggle.com, it's going to send a get request to that address. And it sends a response back, which we see on the screen. But we don't want to go there. We want to go HTTPS. And we'll go to our local host. And we'll go to port 8080 on that local host. When we do that, if we've actually spun this up and running, something's wrong with what we're doing. Let's go back and look at our code. All right, so we know it's running on port 8080, and yet we're not hitting it. I hope I don't have something else running on port 8080. We've thrown an error. All right. Can't provide a secure connection. And this is the very real stuff that happens, because this was running on Wednesday night, wasn't it?
It was.
All right, so let's do, I want to Google search. All right, there it is. Yeah, we haven't configured anything yet for running a secure domain. We have HTTP, not HTTPS, and that was my mistake. Okay, good. So we have right here a time date stamp for when the response came back and where the response came from, and the message you made it to the root of the app. We could also go here and inspect, use our developer tools. And if we look down here to the network and we click refresh, it'll send the request again. We can see the request goes into the local host. We're issuing, you can see it right there as a get. and we got a response back. If we look at the response, it's this JSON formatted text. It's just text. There's nothing special about it. So we know that our application is up and running. All right, so we already know that we're building an API, and we need to be able to essentially do CRUD operations on 4 different entities. So I kind of want to take a moment and show you how we would design this application. Now that it's up and running, let's just leave it running, and then we will switch over here to my iPad. I'm going to try out yet a new drawing app. Let's see how well Eric does on this. Okay. So interesting. Okay. This is our API. Nope. I have a drawing tool, and what I've been told is I can go like this, and look at that, it turns into a square automatically. I thought that was pretty cool. So let's move this over here and just talk about what it's going to do. Here's a text box, and this is our API. And we're basically going to create in here what are called endpoints. And those endpoints are distinct places we'll receive HTTP requests. And so we need one for addresses, another for customers, another one for product, and what's the last one?
I can't see my notes.
Orders, that's right. All right, now let's backspace and do a capital A. Okay, so let's see if we can widen this a little bit. Okay. So inside here, not that. What's going to be inside our API? Well, we need, nope, I'll get this down. A router. So this is called a router. And let's see if I can actually make the text part of this work. I don't know if I can. Why is that so large? There we go. There we go. That's a little easier to read. Okay. And this is where the HTTP requests come in. Okay, good. Look at that. Hey.
Nice.
So I can have a request come in here. Now we're then going to send that on. Really? You're doing so well at making rectangles. Okay. This is going to be, and I think I can take this. I can move it. Good. Let's call it controller. This is where our actual logic is going to happen. And the types of logic we're going to implement are CRUD operations. And then we also have down here, look at that. Hey, that's our database. Ooh, I'm so good. All right, the controller is what's actually going to have two-way communication with the database. And of course, the router is also going to have two-way communication with the database. Let's see if I can get better at this. If I circle this whole thing, I think I can move it over a little bit. Look at that. Okay, good. Wow, if you don't do a really good job drawing a straight line, he gets mad at you. All right, good. So this is what we're going to build. The router also is where the responses are going to leave. Let me take this, move this whole thing down a little bit, and we're going to draw something leaving. Here we go. And that's the response. So this is what we need to build, which tells us, just in terms of organizing our code, we need to have a folder for routers and a folder for controllers. That's the first thing we know. So let's go ahead and start building out this structure. Any questions about what I sketched there?
No, I think we're okay. So now we're going to be building, which part we're reading right now from the sketch?
I'm gonna build both a router folder and a controller folder. There's nothing in them yet, okay? But I just want to add them in. So I would just go down here and do new folder. And I do router. And then on a new folder. Actually, I'm gonna have a top level folder called source, which is where all my source code goes into. And so I'm gonna move router down inside that. Okay, good. And now on that source folder, I have another one, and this is going to be called controller. So now I have two folders in there. Now, when I'm building something like this, I move in tiny bite-sized pieces. So the first thing I want to do is make it so that inside this router, there is one JavaScript file that I can send an HTTP request to from the server.js file, because it's really important to understand that this is where all communication comes into our app, is this exact file right here. Now we could just take a big old chunk of this file and just start defining routes right here. And we could literally say, you know, if we get app.post and it is on a pattern of address, then we need to take our request and response, pass them into a function, and call the controller. That's what the code will kind of look like. We could do that right here, right inside this server.js file, and our program would work just fine. But if you can imagine, we've got CRUD operations times how many?
4.
we have all these CRUD operations. We have 4 for this and 4 for that and 4 for that. We're at 12 already. We have 14 CRUD operations to build out. That it just gets cluttered. And so in terms of organizing our code, instead, we don't want to put all of this route information here. We want to make a separate folder and point to it. So in this router, the first thing I'm going to do is make a file that is route.address.js. You can do double dots in the names, by the way. It's a real nice way to be able to make code readability happen. Route.address.js. And so in here, I'll just put receives HTTP request from server.js, just for context. And so what goes in here is has the route handlers. Well, I already kind of built one over in server.js just off the cuff. Let me go ahead and steal that and go back. Yep.
Okay. So let's just back up a little bit.
Yeah, for sure.
So we're not doing inside just because code readability.
That's easy for you to say.
Yeah, thank you. So that's why we're building the other in a separate folder. And then, so what is the folder that we're working on now? It's route address.
The folder is router, and in it, I made a single JavaScript file that'll receive all requests related to addresses.
Okay.
Yeah, go ahead.
Do we need to somehow kind of connect the 2 folders right now, or this will happen later?
You're a genius. That'll be the very next thing we do. And we'll do it from this file you're looking at right now, server.js. We have to wire it up on both ends, Carolina. That's exactly the right way to be thinking. Cool. So I can start anywhere I want to. I prefer to start down here in the router, only because when I'm trying to build, to make the code here in the server, Visual Studio Code will prefetch information from here for me and make it easier. I'll show you how that happens.
Okay.
So any other questions?
No, I'm just behind on the coding. I was watching you in the just trying to catch up.
Yep. And the other thing, just for our audience members and for both of you to understand, this is something that I would do all on my own without any junior developers, right? And what would be the point where a junior developer would come in is when at least one of these full routes was fully built out.
Okay.
So that if I asked you to build in the other CRUD routes, you would be able to see a fully working example of it and go, oh, well, someone already was here ahead of time, and let me just see the way they did their code. And honestly, you can copy a lot of what they do and then work out the kinks. You don't have to come up with everything all on your own. And by the way, that's the thing I want to stress for you and for our listeners is you're not expected to memorize everything, and you're not expected, at least in the first part of your career, to be able to just come up with this stuff. And frankly, I've been doing this for a very long time. Most syntax that I would write, I would actually even just look up. I happened to get that one right. I was lucky that time. Typically, I would literally look up creating a route for Express.js, and I'd find the syntax for it. You don't need to memorize that kind of stuff. You just need to know that that's the thing to do, and then Google it. All right, but right now, let's go ahead and take this. I don't know if I have it in my clipboard or not, so I'm going to copy it. In fact, I'll just cut it. Go here to the address, and I like to comment my code a lot. So I'm just going to say, this is going to be create new address, because that's what a post is. So I paste it right here. This is roughly what it's going to look like. Now, wiring it up is going to be kind of interesting. Just bear with me on this, okay? But I need to point to this. Now, here is, which is exactly what Carolina was talking about. This is where I would just look it up, because again, I'm not going to reinvent the wheel. So let me do that in front of everyone so they kind of see what I'm looking at, okay? If I have, I would be going Express app setup router, because so many people have solved this. There's Express.js, and they give you a lot of guidance on this. Routing refers to how an application's endpoints, its URIs, respond to client requests. You define routing using methods of the Express app object that corresponds to HTTP methods. So we have an app object. You see how app right here? Do you see that that's monospace? You see that that's referring to an actual code item. We have an app object. We made it in server.js right here on line 5. It's super important to remember from that point forward, anywhere in your code, you can have access to this running computer program and do things with it. And it comes with a lot of things. It comes with built-in functionality for handling requests and responses. And behind the scenes, when it receives a request, which is just a text document, it's actually making an in-memory object called a request that has a lot of properties and a lot of behavior that you can do with it. For example, on line 8, in memory is an object called a response. And one of the properties on it is that you can attach to it a body and you can format it as JSON. And you do that with one simple line. You do .json and it creates, and you can see it above it. It says send JSON response. And that's all part of this Express object. Typically it's called app. And so when we look here, it says you define routing using methods of the Express app object, that we have an Express app object that correspond to HTTP methods. For example, app.get, app.post, okay? So this is how we would do a very basic route. I actually kind of wrote this from scratch yesterday. We brought in Express, we made it a running app, and we defined a route. We have that on line 7. Well, now we need to get a little more complex. All right, now all of these for a get and for a post, these are all assuming that they're going to live in the exact spot where the app is, where the app object is. We don't want that. We want our routes to live in a whole separate file. So let's define this, or let's connect the two. If I go down, it'll have how to connect them. It might not. All right, it doesn't. So I'm going to use another example I have that I like to refer to all the time that does show how it's done. Okay. I don't want the front end. There it is, right here. All right. So let's see what we've done. Oh, good. This is what I wanted to show you. We didn't make this yet, and quite honestly, we kind of should have from a design point of view. This is a list of all the actual endpoints that we're going to build. I realize it's kind of stupid not to have done this, so I think we're going to, and that'll probably help a lot with designing what we're going to build. Let me see if I can just cheat. Take this and, oh, I mean to turn on VS 2017. In the README, I'm going to put down here, go away. That was a mistake. I don't need you. Let's go down here in the README and I don't care about the design notes. We're going to have what we're going to call API endpoints table. This is something that you would be involved in designing. So let's see if we can actually make this make some sense. All right, and we'll adapt this to have our content, okay? All right. All right, now, what we're putting in here is we're saying, what are all the specific patterns of how to route a request into our computer program, and what operation or action did they correspond to? So let's do the simplest one, which is just a get address. I'm going to start with address as the first thing I'm going to build out. It just makes things a lot easier. So what this is saying, I'll just have it all by itself, is for people who are trying to use our API, what we're documenting here is how they need to craft or compose the request that gets sent in to the actual API. If they send it to our URL, which right now is localhost port 8080, and then they put after that API/address, we need to make the code that will then send back in the response all of the addresses. That's actually the first thing we're going to build out. Okay. Then there are many other things we're going to want to do. Like we want to get an individual address. So we do get, and we do API/address. And then we're going to pass in the specific ID for an address, and that will get address by ID. Now, if we want to make an address, right, then we would pass in API/address, but it would be a post, which means that we would have to give it the information on the address, you know, address line 1 and 2, city, state, zip, right? You guys following this?
Sure.
Good. All right, and we would want to do the same thing for editing. Do you guys know what the verb is for editing an existing object in an API? Like which HTTP verb do you send?
No.
It's on the screen. See if we can figure it out. It's down below.
Post?
No, post creates a new one.
Update, put.
Yeah, it's put, exactly. All right, so, well, let's see if I can learn how to spell. So we need to send in a, and again, these verbs are just something that when you send an HTTP request, you're sending what verb goes along with it. And the verb for updating an existing object down on the server is a put. So you would do API/address, but you also need to pass the ID of the existing one. So this would be update address by ID. Now I want to point something out really interesting here. If you look at where we're sending the request, this is being sent to the exact same spot as this, API/address. But they produce a different effect down in our code, or we need to make them produce a different effect, because on one of them, we have a get, and the other one we have a post. So one of the biggest things when you're designing one of these APIs is that you're looking at the combination of two things in deciding what you have to do with the request that came in. You're looking at the verb in the request and the actual route you're sending it to. Those two things together tell you as a developer what kind of functionality or what action do I need to build out. So we can do all the rest of them later. We're going to concentrate on just being able to do these things with an address right now. And that covers everything except for we can't delete. We haven't done delete yet. So delete happens to be an HTTP verb. So if I do API/address, now if I were to leave it like that, what would you expect to happen if someone sent a request to that route? There was a delete request. What would be deleted?
All the addresses?
Exactly. You're exactly right. Now, we're not going to give them the permission to do that because we're not even going to build it out. We're only going to say, well, they can pass in an ID and we will delete an address by ID. We're not going to give them, we're not even going to build the functionality that allows a customer service rep to have the ability to delete all addresses. Why would they ever need that? And what if they make a mistake?
Sure.
Good. Okay. So now we have 5 different routes that we need to build just for addresses alone. We need to build in a route if they want to get all addresses, if they want to get a single address and they're giving us the ID for it, if they want to create a new address, if they want to edit an existing address, and if they want to delete an existing address. That's what we need to kind of build out. So again, if we go back to the diagram, the router is going to receive any one of these 5 types of requests. And it needs to send that request down inside the controller. We haven't even talked about that part yet. The controller is where the actual creating, reading, updating, deleting will occur. When it has occurred, we send a response back through the router and then back to the client that asked for that particular work to be done. Are you starting to see this come together?
Yes.
Excellent. So let's concentrate just on the simple thing of reading all addresses. Nice and simple. That's all we got to do. Okay. You don't want to choose a real well, I don't like to choose a real complex one because I'm just getting all the wiring put together. So the very first thing I need to solve is if I'm going to do a get all addresses, how do I get that request that is received in this server.js file to arrive down inside the router for addresses right here? That's the actual first thing I want to wire up. So I don't care even about creating new addresses. I just happen to be typing that one out because I wanted to. But what we really care about is get, and I even sometimes capitalize this in my comments so it corresponds to an HTTP verb, get all addresses. So we know this is going to look like app.get, like we have the app here is going to mean our running computer program, our web program, and it can respond to GET requests. And what you put next is the actual text pattern that defines your route, API/address. That's what we wrote before. If a request comes in that has that exact text pattern in it, hit a comma, what do we want to do? Well, we want to take our request and response and pass them in as parameters to a function. And there's the function. We're now inside a function we're building. Now, right here, what I would do is call the controller. Because remember, the controller is what's going to actually do the work. The code right now that I'm writing, all it does is pass a parameter, sorry, pass a request on. That's all it does. So I'm going to call the controller. Now, I haven't even built my controller. So what I'm going to do right now is if I can reach this, I'm just going to send a response back. I'm going to send it back as JSON. And it's just simply going to be this. I'm going to send a message back with the content. You reached the controller, sorry, the router. And in fact, I'm going to put address router. That's all. I just want to know that I reached it. Because I'm trying to build this in the tiniest little chunks possible rather than trying to wire the whole thing up and then see if it works. I want to see if each separate spot works, but I'm still missing wiring my server.js down to this router. I haven't gotten that done yet. So let me go to a good example of that, which is in here. That's all database stuff. We'll come back to that later. All right. Routes. I am going to cheat. I'm going to grab this. And I'm literally going to put it down here and steal from it as needed. All right, now, here's a whole separate concept. Do you guys know about modules in JavaScript?
Vaguely.
Can you tell me a little bit about what your understanding of them is? It's okay if you're not sure.
I mean, it's definitely related to objects, but
Yeah, actually, it's one of the best ways to think of it. It's sort of a combination of code organization and this idea of objects. A specific JavaScript file, and we're looking at a file called route.address.js. If you're organizing your JavaScript program with these modules, this concept in mind, you can decide if people choose to like use the code in this file, you get to decide what parts of the code are accessible to other parts of the program. You can have things in here that do operations that you don't expose to other callers or other parts of the program. And what you use to define the functionality in this code that is available is by using this module.exports. It defines what functionality gets sent to other people that try to use this code. So inside here is where we're actually going to bring in, where we're actually going to define all of our handlers. So I can actually get rid of all these. I don't need those. We don't have a controller yet. And all I'm left with is what I care about. The Express library that we installed yesterday, and which is down here inside node modules. If we open node modules and scroll down, we have an Express library in here, okay, with a bunch of stuff in it. That library has a function in it called router. You see how it's got parentheses after it. You can call this router function, and what it does is it creates a separate running little program. And that program helps us glue these routes together. So I have one of those. And now I should have erased everything. I don't mean to be doing that. All right, let me leave one of them here. I'll get the rest of them here. Okay, so now I'm left with what I would need. And by the way, this really is what I'd be doing. I'd be doing a lot faster, but I would just go grab something I already know works and that I've used before and use it. So you can see on line 20 how I'm meant to format my functions in here. This is get all addresses is what's going to go here. Now, you can see that we're calling a function that we haven't even built yet. It's from some other code sample. So instead, what I'm going to do is I'm going to take what I built here that this looks like it should work. Everything's the same except for the object at the beginning. I'll take that and I will put it right here. Oh, it was 2 dots. I copied a dot. All right, let me clean all this up. And this is what I'm left with. I have a very simple file. And let's talk about what's in it. Let me fix it a little bit. Okay. All right. So there's not very a lot of code on here. Let me explain what it is that it's trying to do, and then we'll try to wire up the other end of it. When the code in this file is used, a little program called a router will be spun up, and it'll use this function right here to handle any requests that come into it that, one, have an HTTP verb of get, and two, that have this exact text in the URL. If those two things are true, if it's routed to this exact text pattern, and if it's a get, then we'll drop inside this function and we'll send a response back. Now, I don't expect you to remember all of that yet. We need to get it wired up and running. And when you see it work, it'll probably become a little more intuitive. Any questions so far, though?
Shouldn't we change tutorials to addresses or address?
Genius. Yes, we absolutely should. All right, so the last thing remaining is we've got this thing ready to receive HTTP requests. And for one request at least, a GET request to this exact route, we know what to do. We're going to send back this message right here. But we have not connected all this code to our server. Well, we now have a module that is exporting some functionality. Let's bring that into the server.js. So I can go up here and I'll show you the syntax for it. It should be right up here. Routes. No, it'll be in the control. Let's see. Delete. That's controllers. Don't care about that yet. There we go. Server.js. All right. Yeah, then I'll express it. All right, I'll look it up somewhere else. So I need the syntax to bring that in. And I believe it's const. I'm going to call this these are the routes for addresses. So I'm going to call it address router. I don't know if this is correct or not. And require lets me bring in whatever's exported from a specific module. And I like this in Visual Studio Code. It lets me navigate through the file structure. So I'm going under the source folder. And in here, I'm going to my router folder. And in here, I'm going down to my route.address export. And I now have every bit of functionality from that other file right here. I have it available in my server.js as an object called address router. So now I need to connect up this running application to this router. Let me see how to go ahead.
Perhaps a lack of JavaScript knowledge, but this is literally like the same thing as importing and export default, whatever your component name is in React, correct? Like it's the same.
Yes, this is literally exactly the same thing.
Okay.
Yep, it's the exact same thing. Yeah, good call. All right, so let me see some syntax on this.
I'm having a little bit of a time pay attention coding along. So.
Oh, are you coding this?
Yeah,
You
I'm
nerd.
trying to.
It's totally fine. You're gonna have the code base shortly.
Oh,
remember?
Yeah, we're gonna clone it.
You're gonna clone everything I have. You don't need to do that at all.
Wow, I could have been paying attention then.
Okay, here's how you do it. It is still a require. So here under my routes, I do this. I go require, except I spell it right. And I find source, and I find my router, and I find route.address, and watch this. This is just, there's magic happening under the hood here with the Express framework. All I have to do is pass in the running instance of Express. We made one on line 7. There's a running instance of the Express program. It's called app. Right there, I've connected to the router. The require pulls in whatever functionality is exported and attaches it to the running application. And now my running application can reach inside there and send things. So I think it might work. I'm gonna stop my server here for a second. Start it up again, just to make sure it registers all the changes. It's running. Now I want to send a request, a GET request to, if you look at the router, our website, and then /API/address, and hopefully it'll return this. There's a lot of utilities, a lot of programs we could use to send this kind of a request. I'm going to use the actual browser just to make it pretty simple, so you can see it. And then I'll use a different tool to do it. So first of all, let's see if on localhost, all right, so that's working. But now if I do /API/address, let's see what happens. It worked. So I want to show you on a diagram and in the code what occurred. The browser sent in a request. It was received by my router, and it was received by my router because I wired up server.js to do that. It sent the request onto the router, and it matched an exact function inside the router. And because it matched, it did what was inside the function. In the code, the request came in because we were listening on port 8080. We had this route defined, and it scanned through here and said, oh, I think there's a match. And in fact, there was a match for API/address. This is the matching, and with a get verb, this is the function to run. And so that ran the function inside these two curly brackets. And the function just said, create a response with a body that's formatted in JSON, and the contents of that body right here. We can even see it from inside the browser. If we inspect and look at the network, and that's not network, we go network and refresh, you'll see the address right here. That's our request. Let's look at the headers here. Request was sent to 8080/API/address. We send in a get. Let's look at the response. That's the response that we set down inside that router. Any questions about this so far?
No.
Okay, good. We've gone an hour and we got the first part of this wired up. Let's go ahead and take a quick break. I want to find the one that I really like. I can't believe I couldn't find it the other day. I do not want this ugly one. It's just a really nice one. It comes from Google, and it was just always there, and I can't believe it's not there.
So why don't you type Google, online timer Google?
Oh, thank you.
Mhm.
No, apparently not.
Wait. Nope, I'll use that one. Fine.
And it's already set for
Google.
which-
All right, so,
So also
Yeah.
before you go, answer some that I think that some people in the chat asking a couple of questions. So I think
oh yeah, sure, okay. All right. Rukonic really has a great question. Is this a public class? Yes, it is. In that, I want anybody to be able to watch and follow along,
Mhm.
and they can even code along They can, watch the past recordings that are out of my YouTube channel and follow along with everything we're doing. So it's public to that extent, okay? Rather than just me doing it all by myself and just talking through what I'm doing, I really wanted to simulate what it's like when you have a small dev team. Does that make sense, Rakonic?
And then, I have a question.
Yeah.
We are going to be cloning the documents, right? But if the people that are watching us, they would like to clone that, are we going to make the repository public so people can just copy and?
When it's all done, if they want to have a reference implementation, yeah, I have no problem.
Okay.
Yeah.
Okay, cool.
Yeah. They can fork it from theirs, which I'll show people how to do. Okay, good.
Awesome.
Thank you.
Yeah.
Man, yeah, I get buried in it. I kind of wish that for all of this, I just had a producer sitting off to the side monitoring all the different chats and channels and technology and everything like that. But yeah, it's not going to make sense.
The other question, someone is also saying, someone mentions use ES6 modules. And then Rukonic said, right? And then someone says, ideally he should, but I think for teaching purposes is doing it this way to not overcomplicate things. Is that the case?
No, we are now using ES6 modules. That's what that is, right? And I think that unless he means something else, that he or she means something else, that comment probably came back before we started actually pulling in modules, because that's what those modules are, right? There's a few different ways.
What is E6? E6 is just the name, or?
Oh, sorry. You know the language JavaScript?
Yes.
That we're all talking about. It is an implementation of an idea. The idea is a scripting language, and it's actually called ECMAScript, ECMA. That stands for the European Computer Manufacturers Association. Now, the history of that is a kind of fun thing to look up, but for various reasons in the late 90s, that organization over in Europe took it upon themselves to design the specification for a language, a scripting language for use in browsers. Okay. And they defined what it should do. They didn't make one. They said, if you're going to make a language for the web, this is what it should look like. Okay. That's what ECMAScript is. There may be other implementations of that idea, but JavaScript is the only one I really know about. So when we talk about JavaScript, you hear this word ECMAScript or ES all the time. That's because they're the people in charge of setting what JavaScript should be. Now, the fact is, it's the manufacturers of individual browsers that decide whether they're even going to implement it that way. They don't have to, but they kind of have to, or their browsers give different behavior for different code, and it's a nightmare.
Sure.
And even with all that, they're not all 100% consistent. So that said, ES6 or ECMAScript 6 is a version that came out around 2015 that had a huge number of extremely important upgrades and changes to the JavaScript language. And so when people say ES6 features, they mean different syntax that was available, different types of objects that could be created, different code organization strategies that were made possible because of that change that happened. And further, when they say ES6, they kind of lump almost all of the things that have happened since 2015 in, because every year after that, they added more and more upgrades to the JavaScript language. So a lot of people say ES6 plus, and that basically means any modern from 2015 on features of JavaScript. Okay. Does that explain that?
Yeah, no, absolutely. Yeah, I had no idea. Okay, great.
Yep. I see another first time chat, Jewel4N. It's totally, he says, oh man, I missed an hour. I'm sorry, but 24 hours, one, Twitch will have the stream immediately afterwards. And two, 24 hours later, I upload all these onto my YouTube channel, right? Which is, I Explain Technology. I can even give you a link in the chat right now. Hold on a second. That's a link to the YouTube channel. And so 24 hours later, all of it will be up there, and so you can watch the first hour, right? Good.
Rukonic replied back.
Excellent. Yeah, you're totally right. the idea of even using Express for this, Raconic, is something that I debated with quite a bit. The fact is, it's got a lot of issues and problems, and I don't like to use it a lot. There's a few new things that I wanted to try out, but I didn't want to be doing the learning of that in the middle of also demonstrating the whole MERN stack to people that are relatively new to the subject. So you're going to find some older versions of older language features mixing with some new ones. The cool thing about JavaScript is, one, they'll all work nice together. Okay, they'll still be pretty decently supported. And two, it kind of reflects what you're going to find when you go out into the real world. You're going to find projects that were made 3, 4, 5, 6, 7 years ago that still compile just fine. They work, right? They may have had tiny upgrades over time to keep them working, but they work and they're alive. Rather than everything being made with brand new state of the art, or all existing projects continually being upgraded. We don't have time to get back to those a lot. So perfectly valid point. Just building it the way it'll work for right now. I like
And you
that.
still frequently see people using floats as well, just in their, CSS.
Yeah, exactly. And by the way, that's just and then we really are going to take a break, but that's just another big thing to know about web development in general, is that it is a constantly changing ecosystem. So you've got to be committed, as I know you both are, and as I can tell a lot of people in the chat are, you've got to be committed to a culture of constant learning and constantly staying up to date. Now, that said, even though things change rapidly, for as long as is feasible, most people are making tools inside the technology arena, try to keep them backwards compatible and running for a long time, because to do otherwise is to risk them not being adopted, because enterprise software usually needs to exist in a relatively stable state for quite a while before they just kill it off. That process is called sunsetting. When you get rid of a piece of software and phase it out for a replacement, it's called, sunsetting. It goes off into the sunset. So, okay, cool. Let's I'll take 10 minutes, and then we'll pick back up where we left off.
Great.
That's good.
All right, I'm back.
Yep, me too.
Eric,
Hey.
I sent you a message on Twitter.
Oh, sure.
Hi, Corey. I see you. I see you on Twitch.
Yeah, friends. Watching?
Yeah. Yeah.
Excellent. All right, cool. Okay, welcome back. All right, by the way, I found an alternative. What do you think? Is that
Wow.
big enough?
It's a lot better.
Beautiful.
Okay, good. All right, so let's get this wired up. We know we've got part of it working, which is wonderful, right? We've got where we have an HTTP request coming in through server.js. Because we've wired up the address route file, then it gets checked. We know that we can properly send a GET to this exact address, and it'll get inside the route handler. This function is called, this function right here that's highlighted, that's called a route handler, okay? And we're faking a response, but what we really want to do is actually pass that on to a whole separate place where all of our actual business logic goes, called a controller. So here inside the controller, actually, I've gone on long enough without doing a really important thing. I haven't saved any of my changes to Git, and that's not okay. So Git status. All right, learn in public, really. So I did not turn this into a repo. So I do Git init. And now I have a repository. I'm going to add every single file in this whole folder into the repository. This is going to take a second or 10 because there's about 4,000 files.
Or 20.
Wow. I'm going to make a file in here called .gitignore. And in here, I want to put node_modules. I don't want that folder used. Let me make sure I'm formatting the right way. Gitignore syntax. A gitignore file specifies intentionally untracked files that Git should ignore. Each line specifies a pattern. So gitignore node modules. Now, here's what I'm doing. I don't want Git to track changes in this node modules folder because I don't want those to all be shipped out to source code. I probably should have done that gitignore before I did the add.
Git add, yeah.
But I'll reverse that later on if I need to. In fact, I'm not going to worry about that part right now. I want to get on with some of the coding. So fine, I have that in there. I can correct it later if I need to. What I really want to do is start making this do a commit. Initial commit, routing setup. Okay, good. So that's a nice stable place to have done a commit. Now let's get a controller going. I have a folder here and I'm going to put a file in it. It's called controller.xml. controller.address.js, same sort of like pattern, controller.address, route.address. And in here, what I want to do is define the functionality that's going to handle my actual CRUD operations. This is where I'll have to eventually interact with the database to read information and to update information and to insert information, right? So let's look at how we're going to build that controller out. Again, I'm just going to be a lazy developer because we're all quite lazy. And I'm going to look at how I make the controller. All right, controllers folder, tutorial.controller.js. All right, so I don't have models yet because that's my database stuff, but I'm just going to do a bunch of exports.create. So I'm going to export individual functions. Let me take one of these just so I don't have to type it out. Because again, I don't know if you know this, programmers are lazy. So this isn't a create. This is going to be a get, or I'm going to call it find all. I want to get all addresses. So in here, I'm also now going to cheat and just craft a response. I'm not going to reach out to the database. I haven't got that connection set up yet. And I'm going to send a JSON back, right? And same as before, it's going to be a JSON object with a key value pair, message. Let me put the cursor out of the way. And the content is you reached the controller. This is literally how I build this out. One tiny bit at a time. It might go faster than this because I'm not talking through it, but I like to build one layer deeper each time. I started at the top of the application, if you will, at server.js. I made sure that I could send requests to it and send a response back. Then I connected up to a router that I built and made sure that I could send in a request that was intended for that router and that it would in fact send something back as a response. And now I'm going to connect, instead of sending this back, I'm going to connect to the controller and see if it will send something back. So let's go to that controller again, and find all is the function I have. I'm exporting it. So if I go here to my router, I can import. I can do a const controller, and I'll do a require. And I'm going to the two dots navigates me up, go to controller, and then controller.address. I now have access to everything that I'm going to export. I'm only exporting one thing right now in the controller, and that is a function called find all. So in here on my route handler, instead of sending back a response, I can actually do what it says in the comment and call the controller. So I can say, where's the syntax on this? My routers, define routes. And they fill it in. So here's my controller being pulled in as a require. So I replace all of this with a call to the controller and the correct function. So I'm going to replace this whole function right here. Everything inside that. And right here, I'm going to define the handler. So the handler is going to be that controller object I created on line 6. And look, it even reaches inside that code and finds the function that I built, find all. This should wire everything up. Let's spin up the application and see if it works. An error, goody. Let's see. Res.json, you reach the controller. All right, what did I do wrong inside there? controller dot. Guess I did the syntax wrong. What did I have here?
I don't, is it the parentheses at the end of find all?
No, because I'm calling a function. That might not be correct. You're right. You genius. That's Express making things nice and helpful for us. All right. Let's see if that'll do it. Genius. Okay, so now let's send that same get. We have it in the browser, I believe, right here. API/address, refresh. Look, we reached the controller. So again, from the diagram, the request is coming in from the router, being sent to the controller. There's a specific function that is being sent to called find all, and it sends a response back with that message in it, goes back through the router, and then out over to the client, in this case, the browser. So all that is wired up. All right, now, we still aren't able to hit the database. Now, we could stretch this project out by many, many days and go through building all of the database. I'm not going to do that. And the specific reason why is, as you know, as an entry-level developer, you're not going to be tasked with that. There's going to be an existing database in almost every case that you're going to need to build an application that can reach into and operate against. And so we're going to cheat and have an existing database. I do get to show you a couple of things while I make that database, though, because I had one that has pretty much the same kind of structure that we want, but I killed it, or part of it, in demonstrating some, how websites can be hacked for a class. So I utterly deleted parts of the database. But let's start looking at that database. Let me pull up, I said we were going to use MySQL. So if I do pull up Mysql Workbench, I'm going to connect to the running database server on my computer. It's going to take a minute to spin up. Here it comes. I have a local instance of the server running on my local host at port 3306. If I can click on that, it'll connect to it. Here's all of my database. You can see a CSR database. Now, I want something extremely similar to that. Let me close all of these. Make things a little cleaner. I don't want to save anything. No, thank you. All right. All right, now, making this database. All right. Let's see here. Again, this is not a part you do, but I kind of want you to see what happens. I'm pulling up the project that I built that makes that actual database. This might take a minute. There we go. All right, now let me make sure that I have all the dependencies that are needed here. If I do an npm install, it'll check all my dependencies and pull down any updates that need to be installed. Because I haven't touched this application in a while.
So
Go ahead, ask anything you want to.
no.
I'm going to delete this database. And now I believe think it's scripted out that it'll actually build it for me, but I'm not positive. Yeah, it's been a little bit. Oh, that's because we're using port 8080 already, aren't we? It also wanted to use port 8080. It was mad. Let's see if that's what it was. All right. Yeah, that's not it. That's not enough. Okay. Now, this next part, I'm just going to handle because it opens up a tremendous can of worms about how I'm generating this database. Okay. I may have to create the database first. So I do. I'm going to go back here. I'm going to make a database here. I'm going to call it CSR database DB. It's empty. There it is. It has no contents at all. Now I'm going to go back and I use utility here. That will make the entire database for me. All right, now let's look at that database. Do a refresh and open it up. And now I have tables on the database, all the tables I want. The reason I had to do this is because in that class I was teaching, I showed them how to successfully hack into a website and I had them delete the products table. It's very frightening to watch when that happens. Okay, so I have all my tables and now I'm going to put a bunch of data in it to simulate real world data. And that would be this is going to insert 100 records into every single table. There we go. Now, if you look here, we actually have contents in all these tables. So if I go here to addresses, right click and select rows, look at that. It just generated all of these and inserted them for us. So we now have a whole bunch of addresses. We also have a bunch of fake customers, 100 of them. We have a bunch of orders.
Did you write a code? So you had a code that writes all that information?
Yeah, I had the code already. And I'll show it to you real quick to give you a little understanding of what just happened. Okay.
Okay.
I have down here inside my source folder, a Sequelize folder. Sequelize is a utility to help your Node application work with databases.
Okay.
In here is a whole table called migrations. And in it, these, let me widen this, these successive files actually go through and literally, let's see, I'll close that, make it a little easier. They literally reach into the database and create all the folders.
Mm-hmm.
And then products and then orders, and they do all these things, okay?
Wow, that's cool.
Yeah, and then there's another one called seeders, and these 5 JavaScript files add in a bunch of fake addresses and products and such.
Mm-hmm.
They make use of a library that was actually in the news about 4 months ago called Faker.
Okay.
It's a free JavaScript library. And if we go out here and go to faker.js, generate massive amounts of fake data, it's really, really valuable. Okay. Tells you how to use it. You can fake any kind of data, address data, anything. Okay.
Wow.
The reason it was in the news is because the developer didn't tell anybody and he corrupted it so that it would send your computer program into an infinite loop as some sort of a protest against, I don't know, some political thing he was upset about. It's one of the challenges and the liabilities of using open source software. But I don't care because I'm not going to use it again. I already have all my data. But yeah, so that's what I set up is these, they're called seeders, and they put a bunch of fake data in there so that we can pretend we have a fully running company.
Wow, that's amazing. Okay,
Yeah.
thanks.
It was-
Thank you for showing me the backwards.
Absolutely. So what we have right now is, let's go back to our computer program. What I want to do is I'm all the way down inside the controller. If we go back to our diagram, my request can go from the top level, which is my server.js, into the router, and then go down to the controller. But now I need to connect to the database. So connecting to databases, in fact, connecting to any external server is almost always a pain because there's authentication involved. So what I need to put in here is the username and password and such, so that when I send requests from my controller down inside here, that I'm authenticated and allowed to hit the database. Now, again, all this would have been wired up for you, but you'll need to know a little bit about it. If we look at this CSR database, I think if we expand it a little bit and go down, might be under administration, users and privileges. I have, let's see. Yeah, I have a root user that can access anything. Now, this is normally how you configure permissions for a database. You would have individual permissions for different, individual programs and such, and individual users, but it's all my machine. I don't care who accesses it. So I'm going to have to make my code, my computer program, be able to connect to a database that, again, is out on the local instance of MySQL, and then specifically reach into the CSR database. That's what I have to wire up. So I'll show you how to do that in just a moment. There's a case where when you go to do this on the job, someone will already have this information very easy to hand for you and show you how to connect and how to set up your program to connect, because it's never fun. Let me find this. All right. So I'm going to go down inside my folder, and inside my source here, I want a new folder to put stuff related to dealing with the database. Now, since I'm going to be making use of that utility called Sequelize, I'm going to call this Sequelize. Now, I haven't started to do much with it, but I will. The first thing I need to do is make a folder in here that's going to hold a file that's going to hold configuration data. The config data is formatted in JSON, the data interchange format, JSON or JavaScript object notation. And what goes in here is a JavaScript object. It looks like this. Let me go ahead and steal it from over here. All right. we have there the username and password to connect to my local database. We have what server is the database server on. We have what kind of database management system is used, MySQL or Postgres, MariaDB, there's a bunch of them. This tool called SQLize works with any of them. So here we have everything we need. On the local host, we are connecting to a MySQL database. Here's the username and the password. And once you're connected, this is the database you're going to access. All right, so that's there. Now, we're still not done yet because we need a way to connect to the addresses that are down inside the database and turn them into in-memory objects in our computer program. The in-memory objects are called models. So I'm going to make another folder in here called models. And I need a file in here for my addresses. Again, you wouldn't be building all this. You would have it, part of it already built out, and you would pattern what you do after what someone else already built, at least early in the job, okay? Now, I'm going to take a huge chunk of code here. I'm going to steal it because, again, this is something that I would have already done. It takes a long time and you wouldn't be around for. So we're going to pull in the SQLize library. And we're going to create an object called a class called an address. And here we have all of its properties. We already figured this out. Address line 1, line 2, city, state, zip. Remember, we documented that in our README. We have up here for an address, what are the properties we care about? Line 1, line 2, city, state, zip. I don't need to specifically call out an ID because this SQLize program I use automatically creates an ID for you. So I'm mostly there. I have an address. However, I also have this thing called customers. Okay, good, they exist, but I don't have a customer class yet. And I'm referencing a customer class. Well, I would need to create a class called customers. And again, not going to go through exactly how I build all this because it would take, building all this took several hours and would have already been done before you were around. So let me pull in a customer. All right, same thing. We're going to pull in the SQLize library. We're going to make a class called customer. Here's all of its properties. First, middle, last, phone, notes. We even connect to an address. Okay, good. I think we might be good right now. Okay, good. Let's see if we can actually connect to the database now, because we have a connection. Here's all the connections, parameters. We know that there's address data in the database. We know there's customer information in the database. We should be able to connect to this. I 1000% don't expect this to work on the first go through, but that's what we're here for, is to figure this out. All right. So let's see. Let me steal my find all. So let's look at what this does. First of all.
So can you recap? I think I lost you.
Yep,
Are we
I'll
still...
recap all of it when I get it up and running too. And give me just a minute to
Okay, cool.
Wire something else up. All right, so I'm grabbing all the model data. So I have address, I have access to the address model. And then let me specifically, well, I have address to all the models. Const. All right, I think I'm missing one thing here though. Yeah. Here we go. My models, let's sequelize into my models. I need a file in here which contains code that's going to relate to all models, because we're going to have 4 different models: address, customer, order, and product. This code I'm about to pull in relates to all of them. It tells us to grab our config information from this config. Oh, I don't have that in the config file. I need inside of Sequelize to have a config folder. So I need a new folder here called config, and I need to move config.json inside of it. Okay.
Do you need a .env?
Yeah, I do. Actually, you know, we ended up not using the .env. This may or may not fire up. It's fine. We have time. This is what I'd be going through in the real world, is trying to get this all wired up. Let me see if I can get it to work. Let's go. Let's trace. So this is what I would be doing. I go, okay, server. The request arrives. And the only request I'm going to do is get all addresses. So I know I can route to the address router. I go to my address router. And on my get, which is what I'm going to send in, I'll call my controller find all. I'm going to go to the find all, and I'm connecting to the models, specifically pulling out the address model. So on that address model, I should be able to execute what's called a find all. Now this find all on line 5, that is where this library that I've installed called Sequelize can reach out to the database and get every address. Now, what this makes me realize is I might not have installed Sequelize yet. Let me see if I did or not. If I look down at node modules here and go down.
I feel like you did.
There it is, Sequelize. Okay, good. Okay. This might work. Let's run the application and see if we don't break anything. Probably gonna throw some errors. All right, so let's see what we got. All right, so I'm in, let's see, has many columns. Okay, this is a Sequelize thing. Customer.has many. Okay. Orders. A customer has many orders, and I haven't done orders yet. Okay, good. So we're gonna have to put all of them in here. Let's go back up here to the source folder. And let's go to Sequelize into our models. Let's actually make the other ones. New file would be order. All right. And let me pull over order. Here's an order. And the order has a customer ID, order status, text, date, total price, order notes, everything we cared about. Let's just do the last one so don't mess anything up. Product. grab all this data. All right. Let's see if that does it. Npm start. See what kind of errors we throw now. Shut the front door.
Oh,
Server's
second try.
running. All right. So let's see what we get back. Now, so far, I've been sending this in using the browser. We've gone here, I've sent it in. I don't like to do it from here, and I'll show you a specific reason why. I want to be down inside the context of my code when I run this. So there's a few different tools you can use. I'm not going to get into how to use Postman right now. What I'm going to continue to use is what we set up towards the tail end of our last session, which is this little utility. For those of you who are watching and didn't see last session, we installed an extension called, well, that's Azure, no extensions. We installed an extension called REST Client. There it is, REST Client. We have that installed. And REST Client lets us make little files with a .http extension. We have one right here, and actually handcraft our calls. So this one right here, this is get root of application. We know that works. In fact, let's send it. Message, you made it to the root of the app. We knew that worked. Now let's do one that's get all addresses. I'm going to make my own HTTP call here. So I need a get verb. Copy all that because it's the same. But the thing is that after the 8080, I need that pattern API/address. That, let's see what happens. Click send. Holy moly. I cannot believe that worked first time. Look at that. We have all 100 addresses. Those are addresses that we got from the database. The request came in, not from the browser, but from that little utility called REST Client. The request, which was a get API/addresses, went through the router down to the controller. The controller connected to the database, got all the contents of the addresses table, sent them back to the controller. The controller turned them into JSON, sent them back to the router, which sent them back to the REST client. And that's what we see right here. It's the JSON. You can collapse the whole thing. There's our JSON. You can collapse each individual one. It worked.
So we have a question, Eric.
Yes.
We have a question from Joe for Anne, and he asks, so a model is just a class that SQLize is going to use to build a table?
Yeah, that's actually a really good question. I should really appreciate that. And we only have 4 minutes left because we're gonna have to drop a bit early. Let me explain what that is. This is for you and for everybody watching. If we go back here, I'm gonna just choose a free form sort of drawing here, see how well this works. And I talk about a thing called ORM. This
We're
means,
not on your, we're not on your
yeah,
tablet.
thank you. That stands for object/relational mapper. And it has to do with this problem we have that over here in our database, you know, here's a symbol for a database. Over here in our database, what we have are tables. There's all the rows and all the columns of the database. And these databases are, of course, in a relational database. It means table 1 might be related to table 2 in some way. That's why we say relational mapper. But remember, this is just, if you take any particular row, it's just a bunch of fields. Well, over here in our program, our computer program, what our program works with is objects. Now, we talked about this last time, objects are just things maintained in memory that have two aspects. They have properties and they have behavior. Well, the properties for a specific object, we're storing them down in here. Let's just take an address. We'll take address 1. I'm going to read it off the other. I'll switch here and we look at address 1. Let's expand it. And the properties are right here. This is its ID, address line 1, 2, 3. These are the properties of that object. But when they're down in the database, let's go to the database and look at addresses. Let's go up to number 1. Claudia Fort, apartment 439. That is ours. Dang it, I did it again. There's Claudia Fort, apartment 439, right? Didn't mean to turn that on again, I'm sorry. In the database, that's just static data inside a database table. It's of no use to a computer program. We go back here, what the program needs is it needs to read this data and turn it into a live object that it can actually look at the properties of and execute actions on. So we need something in between, and that something in between is called an ORM. It's a piece of software that can take in relational data, i.e. the contents of a row, and turn it into an object. Let's be a little more precise with what we're looking at. We have over here, and if you need to drop off, Carolina, just let me know, or it's totally fine. We have over here a customer table, and there's the first row, row 1. But over in our program, we defined a class. Oh, sorry. I meant we have an address. What is wrong with this? Okay, we have an address table over here. And we have a class called address, and we need to make one of those. So what we do is we send a request from the application through the ORM for the address. It arrives here as a SQL statement. It's basically select, the one we're sending is basically select star, because we did a select all. So it gets every row, sends that stuff back, but let's just consider one of the rows. When it comes back, it again goes to the ORM, and it takes the first item in the list there. It takes item number 1. It says, hey, we have a class called address, and address has properties of line 1, line 2, city, state, zip. Well, guess what? I have this flat data of line 1, line 2, city, state, and zip. I have that, and the ORM creates an instance of the address whose properties are pulled from what it got from the database. So it is an object relational mapper. It goes back and forth between the two. I hope that fleshes out that question. That was a very intelligent question. Whoever asked that in the chat.
Julian, Julian asked.
Thank you,
Either Julie for 4 or Julian, not sure.
Okay. Well, thank you all for that. That was actually really, really good. And again, I went through that whole last exercise pretty rapidly because frankly, it's not something that a junior developer is going to encounter that much when they arrive on the job. They are going to arrive almost always at the beginning with a situation where they're working on an application that one already exists and the basic code structure is already laid down. And 2, it can already connect to and work with a database. obviously over time, you get to the point where you can start to handle more and more parts of that and be involved in the discussions and actual work to create the database, be involved in the discussions and work to implement one of these object relational mappers. You'd be doing all that, but that's just way beyond the scope of what we're trying to do right now. So I just went ahead and built the database, and I'm blown away that it worked right out of the gate. We can get all addresses. So I want to take stock of where we are, so we and we'll know where we're going to pick up. Okay. We had looked at the concept of our overall structure. If we go back to this, we had this picture right here. We are building the back end. Remember, we haven't even looked at the front end client. We're just building the back end API. And what we have built so far is an application that can take in a request. It'll go to a router. It'll get routed specifically to a function in a controller. That controller through an ORM, and I'll actually draw in the ORM right here, because that's still inside our application. Here is the dividing line. I'm going to change this to red. There's a dividing line here where we are no longer in our application. So we can send a request as we can send a SQL instruction. That's not what I want to be doing. I'll highlight. We can send that SQL instruction down inside the database. It'll grab whatever information we need. It'll send it back through the ORM. The controller then can create a JSON. Let's change this back to black. It can create a JSON response, and that JSON response goes back through the router and then back out to whoever requested it. We have now a functioning API. It's only for one endpoint, get all addresses, but it's fully functioning.
Yeah.
And so we're now at the point where you guys can start to build out some of the rest of these, which is what we're going to do tomorrow night. We're going to have you guys clone and get all the material, all the code onto your computers. Okay. Let me stop sharing. You guys will have all the code on your computers, and then I'll have each one of you build out like get all products, get all orders, so you just start to see what that looks like. But
Okay.
there's already gonna be a wired up example for you to operate off of.
Oh, that's cool. Okay.
Yes.
So are we doing this again tomorrow?
Yep. Yeah, if you're down with it.
Yeah, sure. I
Yeah.
don't know. I don't know about.
Yeah. I can't do 6:30 tomorrow.
Uh-huh.
Brandon, you tell me, is 7:30 okay?
Yeah, I may
Is that a little
not
too
be
late
able
for you?
I may not be able to go like 3 hours or anything.
Yeah,
but
I don't want to do that again, right?
Why
We can
don't
ahead.
we keep? Oh, you have class on Monday, right?
Yeah, I teach on Sunday and Monday.
Sunday, Monday. Oh, okay.
Yeah. So even if we only get an hour in tomorrow, I want to accomplish you guys getting the code cloned to your machines, and at
Okay.
least each of you building out one of those routes.
that
Okay.
would
That's
definitely
about- that's
be
about an
my
hour's work.
priority is getting the code and cloning it and everything, getting that all.
Yeah, exactly.
So tomorrow
Good.
is Saturday, so we should do a short session and we can continue on Tuesday, I guess.
Yeah, exactly. Yeah, we can go longer on Tuesday.
Yeah.
Sounds good.
Excellent. Let me pull up the interwebs here real quick and just want to pull up Twitch. And I want to say thank you to everybody who's watching. That's super, super cool. And again, I'm getting the balance right here between working with people in the actual like Zoom call and paying attention to the chat, although Carolina is much better about that than I am. Thank you, Carolina.
I assume it definitely takes some practice.
Oh
Yeah.
man, yeah. I've seen lots of people stream, but there's nobody in there with them. So the only other people to communicate with are communicate verbally and then watch the chat.
Yeah.
But I'm doing these classes where there's people in the class with me. So thank you all for being patient who are in the chat. I really appreciate it. Awesome. Great job, folks. Appreciate it. I hope you enjoyed it, and for the viewers, hope you get something out of it. And again, if a lot of this went over your head, one, make sure you watch the first episode. Absolutely. Thank you, Munchaba. make sure you watch the first episode. It's up on the YouTube channel, right? And then if something else went over your head, just watch from the very beginning today. And again, at the end of all of this, we'll put the repo out there publicly so anybody can get a hold of it and kind of follow along as well. Other than that, have a great evening.
Awesome. Thank you, Eric. Bye, Brendan.
Absolutely. Thank you all.
See you next time.
Bye.